Welcome to this presentation. Today, let's have an insight of OSI model. Established in 1947, the International Standards Organization (ISO) is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communication is the Open System Interconnection model. It was first introduced in the late 1970s. An open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. The purpose of this OSI model is to show how to facilitate communication between different systems without requiring changes to the logic of the underlying hardware and software. The OSI model is not a protocol, it's a model for understanding the designing a network architecture that is flexible, robust, and enterprise. The OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. It consists of 7 separated but related layers, each of which defines a part of process of moving information across a network. An understanding of the fundamentals of the OSI model provides a solid base for exploring data communication. Let us see the model here. So this is the actual 7-layer OSI model. The OSI model is composed of 7-layered architecture. And they are called as physical layer, data link layer, transport layer, presentation layer, and application layer. And the layers involved when a message is sent from device A to device B. As the message travels from A to B, it may pass through many intermediate nodes. The intermediate nodes usually involve only the first 3 layers of the OSI model. In developing the model, the designers distilled the process of transmitting data in most fundamental elements. They identified which networking function has related users and collected those functions into discrete groups that become the layers. Each layer defines a family of functions distinct from those of the other layers. By defining and localizing functionality in this fashion, the designers created an architecture that is both comprehensive and flexible. Most importantly, the OSI model allows complete interoperability here on otherwise incompatible systems. Within a single machine, each layer will call upon the services of the layers just below it. For example, layer 3 uses the services provided by layer 2 and provides services for layer 4. Right? Between machines, layer on one machine with the layer X on another machine. This communication is governed by an agreed upon series of rules and conventions called protocols. The process on each machine that communicate at a given layer are called peer-to-peer process. Communication between machines is therefore a peer-to-peer process using the protocols appropriate to a given layer. All the physical layer, the communication is direct. For example, device A sends a stream of bits to device B at the higher layers. Then, however, communications must move down through the layers on device A over to device B, and then back through this layer. Each layer in sending device adds its own information to the message it receives from the layer just above it and passes the whole package to the layer just below it. At layer 1, the entire package is converted to a form that can be transmitted to the receiving device. At the receiving machine, the message is unwrapped layer by layer, with each process receiving and removing the data meant for it. For example, layer 2 removes the data meant for it and then passes the rest to layer 3. Layer 3 then removes the data meant for it and passes the rest to layer 4 and so on. The passing of data and network information down through the layers of the sending devices and back up through the layers of the receiving device is made possible by an interface between each pair of adjacent layers. Each interface defines the information and services a layer must provide for the layer above it. Well-defined interfaces and layer functions provide modularity to a network. As long as a layer provides an expected service to the layer above it, the specific implementation of its function can be modified or replaced without requiring changes to its surrounding layer. The 7 layers can be thought of as belonging to 3 subgroups called layer 1, 2 and 3, that is physical, data link and network, are the network support layers. They deal with the physical aspects of the moving data from one device to another, such as electrical specifications, physical connection, physical addressing, transport timing and reliability and so on. And next, layer 5, 6 and 7, that is session, presentation and application, can be thought of as a user support layer. They allow interoperability among unrelated software systems. And layer 4, that is the transport layer, it links the 2 subgroups and ensures that what the lower layers have transmitted is in the form of upper layers can use. The upper OSI layers are almost always implemented in software. Lower layers are a combination of hardware and software, except for the physical layer, which is mostly hardware. And now you can see the overall view of the OSI layers, that is D7 means the data link layer at 7, D6 means data link layer at 6 and so on. The process starts at a layer at 7, that is application layer, and then moves from layer to layer in descending sequential order. At each layer, a header or possibly a trailer can be added to the data unit. Commonly, the trailer is added only at layer 2, and when the formatted data unit is passed through the physical layer, it is changed into electromagnetic signal and transported along a physical link. Upon reaching the destination, the signal passes into layer 1 and is transformed back into digital form. The data units then move back through the OSI layers. As each block of the data reaches the next higher layer, the header and trailer attached to it at the corresponding and sending layers are removed. An action appropriate to that layer are taken, and by the time it reaches layer 7, the message is again in a form appropriate to application and is made available to the recipient. And another aspect of data communication in the OSI model is encapsulation. A packet header at level 7 is encapsulated in a packet at level 6, and the whole packet at level 6 is encapsulated in a packet at level 5 and so on. In other words, you can say the data portion of the packet at level n-1 carries the whole packet data and header and maybe trailer, and from level n, right? The concept is encapsulation, and the level n-1 is not aware of which part of encapsulated packet is data and which part is header or trailer. For level n-1, the whole packet coming from level n is treated as one integral unit. The physical layer coordinates the functions required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. It also defines the procedures and functions of that the physical address and interface have to perform for transmission to occur. And now you can see the physical layer is also concerned with some of the features like the physical layer defines the characteristics of the interface between the devices and the transmission medium. It also defines the type of transmission medium. The physical layer, the data consists of a stream of bits with no interpretation. To be transmitted, bits must be encoded into signals, that is either electrical or optical. The physical layer defines the type of encoding. And data rate, that is the transmission rate, the number of bits sent for each second, is also defined by physical layer. In other words, the physical layer defines the data rate or duration of the bit, which is how long it lasts. Okay, so the data rate is also determined by the physical layer. and the sender and receiver are not only must use the same bit rate but also must be synchronized at the bit level. So the sender and the receiver they have to their clocks has to be synchronized. So in order to send the data properly, the clocks of sender and receiver has to be synchronized, right? And in the physical layer is concerned with the connection of devices to the media. In a point-to-point configuration, two devices are connected through a dedicated link, and in multi-point configuration, a link is shared among several devices. So the physical topology defines how devices are connected to make a network, and the devices can be connected by using a mesh topology. That is, every device is connected to every other device, or a star topology where the devices are connected through a central device, or a ring topology where each device is connected to the next forming a ring, or a bus topology, every device is on a common link, or it may be a hybrid link topology, which is a combination of two or more topologies. The physical layer also defines the direction of the transmission between two devices, either simplex, half duplex, full duplex. So in simplex mode, only one device can send, the other can only receive. The simplex mode is one-way communication. In half duplex mode, two devices can send and receive, but not at the same time. But in a full duplex mode, two devices can send and receive at the same time. Thank you.